All right, so in order to progress in our knowledge of how to work with the internet computer, the next big topic that we need to tackle is this concept of cycles. And this is what's going to enable us to actually deploy our creations onto the live internet computer network. So, what have we been doing so far? Well, we've been doing local development on localhost, and we're using a simulated version of the internet computer in order to get a good idea of lag times and also whether if the things we're building actually work. So we're doing testing basically. Now, once we're done, what we want to be able to do is to deploy our apps onto the live network. So then it's accessible by anyone across the internet, and it's also going to be on the ICP blockchain with all of the benefits that it entails. But how do we actually get there? How do we actually deploy our app onto the network? Well, once our app is live on the network, then it will start consuming computational resources from these data centers across the world. So there has to be a way for us to be able to pay to use those resources. And the most common way is to get hold of some of these ICP tokens. So these are the Internet Computer Tokens, and this is a tradable token that can be obtained in a number of ways. The easiest and probably the most straightforward is to simply purchase them or exchange another cryptocurrency for your ICP tokens. So for example, if you go onto a large exchange like Coinbase, then you can buy these tokens, or you can exchange your Bitcoin or Ethereum for these tokens and get hold of some of these. So that's probably the most straightforward. But in addition, there's a number of other ways. And one that's quite interesting is through what's called the network nervous system. The internet computer is controlled by what's called a network nervous system, or the NNS. And this is basically a governing system that controls all aspects of the internet computer. That allows you to basically time lock your existing ICP tokens and create what's called a neuron. And then you can earn rewards by voting on the proposals. So then you have direct control over what happens to the future of the internet computer. And in order to reward you for your participation, you earn ICP tokens. The third way is to get a grant from the Dfinity Foundation. So they've set aside a whole bunch of money, and as a developer, you can submit a proposal in order to apply for anywhere between $25,000 to $100,000 in ICP tokens to help you develop your next creation. And that doesn't come with any sort of caveats. They don't get a percentage of your company or anything. It's just a straightforward grant. And the final way to earn ICP tokens is by acting as a data center. So as we mentioned, Dfinity links together a whole bunch of independent data centers across the world to create a virtual shared computer. So that means anybody with the infrastructure or who can purchase the infrastructure and supplies the electricity in order to keep these data centers running will be able to run a node within the internet computer, and they'll get rewarded in ICP tokens for keeping these servers up and live, available for people to use. So through all of these methods, what you end up with is this ICP token. And once you've got hold of some ICP tokens, then you can actually burn these tokens and exchange them for computation cycles in your canisters. So essentially, you're turning something that is publicly tradable, that can be exchanged, can be bought, into something that cannot be traded, but has value because it keeps your canisters up and running, or allows you to store data, or allows you to perform computations in your web application. And you basically preload your canisters with this computation potential, which is called cycles, right? And as long as you've got enough cycles for the canister to continue performing its computation, then it will stay up. So it's kind of a similar analogy to, say, if you have gas heaters or gas burners at home and you need to go and buy some propane in these cans, and you store them at home so that you can use them as you need them. But then every so often you might run low and you have to top it up. So how are we going to be able to get hold of some of these cycles so that we can actually get our website up and running on the live internet computer network? Well, there's actually a way that we can do this for free. The Dfinity Foundation offers a cycles faucet. They're giving you free cycles in order to build on the internet computer. Anyone who has a GitHub account that is over 90 days old can get access to a free $20 worth of cycles, which allows you to start deploying your Canister smart contracts, to build your Web3 applications, and to get a taste for how to work with it. So these free cycles are what we're going to be using in order to deploy our web applications in this course. But there is a huge warning that comes along with it. Remember that these are treated like money. Once you deplete your $20 worth of cycles, then you won't be able to recharge it unless you decide to buy some ICP tokens and convert it into cycles. So as we're going along the tutorial, I want you to be super careful, especially with deploying to the live network, because the different types of computation on the internet computer come with different costs. And you can see by far the most costly action you can do is to create a canister on the internet computer, which is basically when we first call deploy and put our canister onto the network. Now, on July 26, 2021, it costs about 0.1 teracycles to deploy a canister. These days, I've tested out and it costs a little bit more than that. So we have to be really careful when we use that DFX deploy method when we're putting it onto the network. And if you don't want to deplete your cycles prematurely and get stuck with no cycles or having to buy ICP tokens to convert it to cycles, I want you to watch the videos carefully and maybe finish watching the videos before you actually complete the actions. That way we can try and conserve the cycles that we've got and use the cycles efficiently. So now that I've put that warning out there, it's time to head over back to our project and deploy it to the live internet computer network. So for all of that and more, I'll see you on the next lesson.